after reviewing in your afternoon project, after reviewing like migrations and NSFetch results controller, like how do you feel with them? Like, give me like a 1 to 3 on your comfort level with maybe, let's start with doing migrations. So 1 to 3 on how you feel with migrations. And be honest, like if it's not a 3, that's totally cool. If it's a 2, that's great. If it's a 1, that's great too. Okay, cool. All right, well, the good part is we're going to be doing some more migrations today. So we get sort of another chance to go over them. What about your comfort level with NSFetch results controller? It's a love-hate thing, yeah, for sure. I'm not sure if I ever explicitly said this. I might have mentioned it once yesterday, but now that I think about it, I don't think I did. That whole extension of the NSFetch results controller is a great thing for you to make a code snippet of, because it's so generic that it'll work in any project that you want to use an NSFetch results controller in a table view with. So it's not like you have to rewrite that every time, because it's just the same code. So if you want, and if you haven't done that already, I would more than encourage you to just make a code snippet of that, because that's just good to have around. So, all right, we'll give it a couple minutes. Welcome to those of you who just joined. We're going to be doing some exciting stuff today. I'm super stoked. Okay, let's go ahead and get started. So what we're going to be doing today, let me pull up the training kit content, is we're going to be talking about sort of where you want to have a situation that is probably more real world. So as an example, have you ever opened an app like Instagram or Facebook or Twitter? Those are just the ones I can think of off the top of my head that I know do this. When you didn't have an internet connection, when you didn't have like Wi-Fi or data, and you still saw some posts, like it would let you scroll through some things. Has anyone seen that before? Okay, if you haven't, generally what happens is, what I'm trying to illustrate there is most apps, most large apps that have sort of that kind of a functionality are going to make it so that you have a little bit of 2 types of persistence in the app. So on one hand, we've got some local persistence that's getting stored on the actual device itself, which would be like what we've been doing this week with core data. Now, the other one would be where you've got the data also being persisted and saved on a server somewhere. So it's sort of a combination of this week's content and a little bit of the networking sprint. So what we're going to be doing is making it so that we can essentially do that, where we have 2 databases and we synchronize them together. And so what we're going to be doing today specifically is making it so that we can send persisted managed object data, like core data objects, to a server somewhere via a put request. So we're going to be doing a little bit of networking today. And then we'll be talking about NS predicate, which is a really, really cool way to make our, this is, I think, where core data becomes very much more powerful than something like user defaults. But basically, it makes it so that we can filter out we can specify what objects we want out of core data, instead of like we've been doing right now is just fetching everything. That's great for a lot of cases, but sometimes we say, I only want these specific tasks or whatever from core data. So that's a really powerful tool that we'll be learning about. And then same thing is sort of on the similar note as the first one, is syncing server modifications. So for example, if you've got maybe the Tasks app on your phone and you've got the Tasks app on your iPad, if you make a change on your phone, we're going to send that up to the server via put. And then what we're going to do is make it so that our iPad can also see those changes and grab those changes for itself as well. So it's kind of synchronizing both ways, essentially, between those two objectives. So give me 1 second. My trackpad's kind of freaking out here. So the server that we're going to be using in order to facilitate this is Firebase. And I don't think we've talked about Firebase before. Is that right? Does that sound familiar? Okay, cool. All right. Let's talk about Firebase real quick and kind of what it is. Firebase is, if you just go to firebase.google.com, it's basically you would call this like a backend as a service, I suppose, although it does a lot more than just like a backend database. But it's a way for you as a non-web developer to, have access to be able to store things on a server somewhere. It's basically like they've kind of written out the software to do that. You just access it through a variety of ways. Okay, no worries, Percy. So as an example, what Firebase can do is we're just going to use it essentially as a REST API just to store some JSON. But you can also do a lot more things like store large files like videos, images, etc. Web hosting functions that are kind of like some code that runs on the server side. There's kind of a lot here, but ultimately, and authentication is cool too. Ultimately, what we're going to use Firebase for is just getting its JSON and putting some JSON there. So you kind of have to do a weird thing to get the JSON itself, but ultimately all of this stuff right here is just some JSON. There's like a fancy user interface to, look at these inside of this dashboard, but ultimately it's just JSON. What I'm gonna do is kill all of this data though, because it's not for this project. So what I'm gonna do is just pull up the solution project in the simulator, and I'll kind of show you what's gonna happen here. One really cool thing about Firebase is it's called like a real-time database, or at least this is one of the 2 databases you can use. If I, for example, like save this, you can actually automatically see that change happen on Firebase like immediately, which is really cool. Same thing if I like delete this one. It should delete it. Well, that's okay. We didn't actually do deletion yet, so. But that's essentially what we're going to do. So that means now when I get rid of this app on my phone, on the actual device where the core data persistent store is, if I run it again, it'll go ahead and fetch anything that is in Firebase. So we've kind of got that 2-way communication going. Are there any questions before we, just about kind of what we're doing, or about anything in general before we dive in and actually talk about how we're going to do this? Okay, all right. So yeah, let's talk about some stuff. Obviously, we're going to talk about some stuff. I want to do another one of my famously bad drawings and see if we can get a little more solid understanding of ultimately how this has to work in order for us to sort of interact with each database and do things correctly. So what I'm going to do is, for example, just going to add maybe like one more task here just so we can see. Okay. So I'm going to break my solution project on purpose because it'll illustrate a point that I would love to talk about. Which is, let's see. Yeah. So we run into, it's not a, well, it's sort of a problem, but it's just, we run into something we need to think about when we're dealing with synchronizing two databases together. And that is that it's really easy to basically desynchronize them or duplicate data. And that's essentially what's happening here. So every time I refetch, like every time I run the app, I'm going to Firebase and seeing, hey, is there anything new? And you'll see that if I do this incorrectly, it's just going to fetch these over and over again. Even though we only have these two things in here, it's just saying like, oh, sweet, I'm gonna go grab those. But we're not really checking anywhere to see like, does that already exist in core data? And if it does, we don't necessarily need to make a new one. If anything, we might need to update it and say, hey, you know, I've changed the name here, so we need to instead just update this and not make a duplicate one like it's doing here. So I'm going to try to kind of illustrate this, this process here. All right, well, I'll try to find colors in a second. Hopefully this is black. Okay, it is good. All right, so essentially what's happening here is we've got two different databases that we need to deal with and figure out how to interact with. So on one hand, sort of down here, we're gonna say, this is our phone. We have down here, core data. Then up here, this is gonna be a really bad rendition of a cloud. On the server, we've got Firebase. So as an example here, if we've got task 1 and task 2 just represented kind of as what I've got right here, in Firebase, what we need to do is say, hey, I need to grab those and bring them down into core data, and so that I can have task 1 and task 2 on my phone as well, right? So this would be just like fetching from Firebase, not Facebook. But then again, the next time this runs, if we were just to run this code again, just kind of the way that it is in a basic form of just fetching and initializing a task, we run into this problem where we're going to get a duplicate. So we have another T1 and another T2. So does anyone have a guess on how we could sort of prevent this behavior from happening? And it's not, I'm not looking for code, but just like a conceptual explanation of like how we could sort of prevent this behavior of duplicating the data when we fetch it.
Can you strip the model of its core data? Does that basically prevent it from duplicating that from the core data?
Yeah, you're on the right track.
Can we check first if it's on core data before fetching it again?
Yes, exactly. So what we're going to do is let's see, I'm going to say, I'm going to kind of draw back here. So I'm going to sort of make a funnel. So we've got like T1 and T2 here. What we're going to do is sort of stop it during this fetch, and we're going to say we need to check if it exists in core data. That way we can say, okay, well, do we need this one or not? So maybe then we have also a T3, right? So we're going to basically run through each of these. And at this sort of, you could think of this as sort of a checkpoint. We're going to say, do we have an object that is, T1 in our core data store? So what we could do is we could say, if so, well, let's talk about if not. So I'm going to say, we're going to kind of separate this out here and say, like, this is going to be like our create task sort of funnel here. And so we can say, yeah, you've got a direct, drawing's hard, guys, I'm sorry. You've got sort of like a direct access to go to core data and go ahead and create a task. That's totally cool. So we just run a check and see if it exists. But what if, for example, again, maybe I make T1 and it's like I'm going to say 1.1, so we just change something a little bit about it. We still want to keep those changes around. That's still good information. We're sort of going to assume that whatever information is on the server is going to be like the most up-to-date information. So if you on your phone, you change this to just create a task, then we're going to say on the iPad, we want this newer version of this task object. Does that make sense? So then we're also going to say, so for the created task, we're going to say like T3 fits that category. And then we're going to have like another funnel where we can update a task that already exists. So that would be like T1.1. Sorry, that's getting a little bit dirty there, but and that's essentially the funnel. So like, for example, T1.1 would go here, T3 would go here. T2 though, it's like, okay, well, that didn't change at all. Let's say it hasn't been updated and we've already got it in core data. So we can just say, yeah, you can kind of just discard that and remove it. And just not even worry, or not, remove isn't a good word. Maybe just not do anything with the fetched one and just not put it in core data at all because we already have it. Does this flow kind of make sense? Okay, so then let's say on our phone, we've got like T4 here. We make a new task. When we hit the save button, what we're going to do is just send that up to Firebase. We'll just say, in our save action, like I'm going to say ID action.
Spencer?
Yeah.
Usually, right, how granular does it go down to, or does it just go down to like the object level?
As far as checking if it already exists?
Yeah. Mm-hmm.
You can be as granular as you want, and that's the cool part, is we're essentially going to come up with the logic that is sort of this checkpoint here. And we're going to use a really nice tool that basically says like, hey, it basically makes it so we know if one task is the same as the other. And then from there we can kind of say like, do we even care to update things? I mean, it really is sort of dependent on the use case, but this is sort of as full featured as I think we can get, where we're not just creating new tasks that we don't have in core data, but we're also updating ones that just have changed in Firebase.
Like if a task has one more attribute, or can we get it so granular so that we could check for certain attributes of the task
and determine whether we need to make a new one or update it?
Yeah.
Yeah, that's essentially what we're going to do.
Oh, okay, gotcha.
Yeah, I'll make sure to kind of go back and sort of hit on that point when we get to that point especially.
Okay, thank you.
Yeah, you're welcome. But this flow is ultimately how we sort of we go from the phone, saving some new tasks, or updating them, right? Because when we save, we either save or update, and then all we're going to do is just say like, hey, go ahead and throw this task back onto Firebase with either a brand new task or an updated version of the task that already existed on Firebase. And then the same thing, the more slightly more complex part is sort of this whole, how do we fetch from Firebase and figure out what needs to be put onto into our core data store so we don't have duplication of data. So when we do that, now I can run this, and I'm gonna get rid of all of these though. And what you'll be able to see is like on Firebase, I've got a task that like doesn't exist, for example, and I've got one that I've changed the name on here. So when I run this again, it's going to fetch the new one and also update that one with its new name. And we don't, have any duplication or anything, but it's just like, hey, I'm going to replace the Z created task with this created task because that's what it's been updated to on Firebase. Okay, can you give me a 1 to 3 on how you feel conceptually with kind of what we're going to be doing today and how, like, not how we're doing it, but like how ultimately this flow is going to work? I think it'll help a little bit to see it in code, but if you have any questions, please feel free to ask. Okay. That's okay. I think that's about where I'd expect you all to be. So let's go ahead and do this now. So I'm going to just close my iPad and we can actually get into the code here. So one thing you'll notice that we have in here is an identifier, and this is something we don't have in our current version of the model. And this is sort of partially going back to Percy's point, which is how granular can we be in making sure that, like we basically need a way to say what qualifies one task to be different than the other task, or what qualifies one task to be the same as, another task. So when we've got a task in core data, how do we know what its counterpart is in Firebase? And that's sort of the ultimate issue that we have to resolve here. And a great way to do that is with these identifiers. And these are a very specific kind of identifier. So I'm going to just go ahead and watch me here for a second. And I'm going to pull up the UUID struct. This is awesome. I really like showing this one Stack Overflow answer because I think it really well illustrates how unique these are. But this UUID is using this RFC 4122 version 4 sort of format of a unique identifier. But ultimately what that means for us is they're always in this format of a bunch of hexadecimal characters with 8 characters, then a dash, then 4, then 4, then 4, then 12. That's really all it means. It's just this jumble of letters and numbers that represents a unique identifier. So every time you make a new identifier, it's going to have, just a different jumble of characters here. So just as an example here, it's really easy to make one. I can just say like let identifier equal UUID, just open and close parentheses. You don't have to give it any information, and it will spit out a random string of characters here. When I run it again, I get a new one, and so on. And so what we're going to do is just say like, hey, every time we create a task, let's just assign it one of these identifiers. And that's ultimately how we're going to sort of be working this. This UUID is itself a full struct, and so really all we care about is the string of characters, and what we'll be doing in order to get that out is we just say .UUID string, and it's the same information, just like without any extra information attached to it that we don't necessarily care about, like this description or hash value or anything. All we really care about is just having some unique identifier that we can attach to this. And you'll see here the identifier is just a string itself.
So Spencer, if you had a database of 1,000 messages and you wanted to, you would use UUID in order to give each message a unique identifying. I guess I'm just curious when you would use this.
Yeah, anytime you want to uniquely identify one object from another.
Okay.
At all. This is a really common, like, just Apple environment UUID. Like you even, there's this, if you ever go into the terminal, there's this UUID gen like command, and it will just spit out one of these for you. Like it's used all over in Mac OS, iOS. It's just super common. That's more than anything, just to show you like that it's used a ton. But this isn't the only kind of a unique identifier. There are different kinds of identifiers, sort of, I guess, formats. And like you can see here, going back to this initializer, it's just, this sort of version, this standard that people use for identifiers, but it's not the only standard. So I don't think I can really well show this. Let me see if I can quickly find a Firebase identifier. I just tend to use UUIDs all the time, so. Oh, that's the same one. There we go. So like Firebase itself uses like this format of identifiers. So depending on who you are, you just use a different identifier. So what we're going to be doing today is sort of setting it up so that the type itself is a UUID object and it's following this very specific format, but it doesn't mean that this is what you will always use. And so in your afternoon project today, you'll also be using an identifier, but you'll just make it a string in order to sort of account for like, there could be other formats that you use, but the way that you use the identifier is the same, if that makes sense. So to go to my favorite Stack Overflow question, how unique are UUIDs? This is the best. So basically, this first part says, you're more likely to get hit by a meteor than you are to generate a duplicate UUID. And then this last part is the best. It says, in other words, only after generating 1 billion UUIDs every single second for the next 100 years, you might have a duplicate with a 50% chance of having one. So it's like super unique. You can be sure that when you make one, you'll never have, like, the chances of you having a duplicate would be astronomical. So I just think that's really interesting and kind of a good illustration of like why we use UUIDs, because they're a very easy and sort of tried and true unique way to identify things, and that's what they're used for. So let's go ahead and implement this. Let's make it so that our model will sort of be in this format of having an identifier as well as the name, notes, and priority that it already has. So what we're going to do is just do another migration here. We're adding a new attribute, and so in order for our core data model to not freak out the next time that we load the app, we need to make a new model version so that it can migrate from tasks 2 to our new model version. So let's just click on one of the data model files. It doesn't matter which one. And we can just go to editor and create model version. And again, like I'm just going to say like the version name is tasks 3, and that's completely fine. But if you wanted to, you could give it some name that makes sense, like tasks with identifiers or something. I don't know. And this is a little bit more interesting now that you'll see this based on model. We can actually say, hey, where do you want to sort of start as the foundation for this new model version? Do you want it to be tasks 1 that just has the name and the notes, or do you want it to be tasks 2 that has like the name, notes, and priority? And for us, we do want the priorities. So we're going to say we want it on task 2, but you can sort of choose.
Sorry, could you go through that process again? My computer decided to freeze.
Yeah, for sure. So just select one of these data model files. It doesn't matter which one. And then just go to editor and add model version. And then you can just hit finish and leave everything as is. Now we'll have this new tasks3.exe data model. So go ahead and select that specifically. And we're just going to add on a new identifier property. And I'm going to make this a type UUID. I just want to point out, like a lot of things, I'm just doing this because this is what I would call it, but there's no special meaning behind the name identifier. You could call this ID if you wanted to. You could call it anything. It's just that the type is UUID, and that's kind of what matters today. So yesterday when we made the priority, we said, hey, I don't want this to be optional. I'm going to give it a default value, right? Because we said, I want, a task to, even if it's old and being migrated where it didn't have a priority, I want it to, just start it like normal. And that's what we said here. For an identifier, we could choose to do the same thing. Oh, sorry, there we go. We could choose to do the same thing where we give it a default value, but in my opinion, this is a time where I don't necessarily feel like it's a good idea to give a default value, because the whole point of a unique identifier is for it to be unique. So if we migrate over 1,000 tasks and we give them all the same default value, that kind of defeats the purpose of a unique identifier. So what I'm going to do is just leave this as optional. And then there will be a point later on, it's actually going to be when we save the task up to Firebase, that we then assign it an identifier, and then from then on, it will have one. Basically, the first time that we need one, we'll just give it one, sort of encode later ourselves. So I'm just going to leave it as optional, and that's completely fine. All right, who can tell me how we make it so that our code will use this new version of our model?
Don't we just have to go through and add all of that in?
Yes, we do. But in order for us to add it all in, like, it has to actually recognize that the identifier exists. So like, don't go here. But if I just go and create a task here, I can say task.name, notes, priority, but it doesn't recognize that there's an identifier.
We go to the model version and then current change to version 3.
Yes, exactly. So let's go to the file inspector, this little piece of paper looking icon, change the current model version to tasks 3. You were just like getting ahead of me, which is awesome. I guess I didn't ask the question well. I apologize. So now we can, say like task.identifier equals something, and it knows that there's an identifier there, which is what I'm looking for. So now what we can do is what Jerry was first saying, which is we just kind of have to go through and like update the model controller, view controller potentially. And this is where I can't remember if I actually wrote it somewhere. I don't think I ended up writing it anywhere. I feel like I did though. Oh yeah, right here. Okay. So we're going to kind of go through this process where we update the data model, which is what we just did. So we'll update the model's initializer. The good part about this is the identifier is all sort of just behind the scenes. There's no actual view that's going to like display that identifier. It's just sort of for our own purposes, not necessarily for the user. So in our case, there's actually not anything we'll have to do with the views or the view controller. It's just going to be sort of on the model and model controller side that we need to update things, which makes it a little bit quicker for us to migrate. So let's start with the model, and let's just give an identifier here. So I'm just going to, just for purposes of keeping everything a little bit easier to read, I'm going to put these on new lines. You don't have to though. And I'm just going to add an identifier argument. And then what I'm going to do is actually just give it a default value here. And this is the cool part of like the identifier all being sort of backward facing. It's not from user input or anything. I can just say, yeah, well, as soon as we make a task, we can just give it a default value and for an identifier, because we don't care what the identifier is. We're 99.99% sure it's going to be unique. So what we can do is just say self.identifier equals identifier. Just as a note, this self.identifier didn't autocomplete for me. This is just a time where Xcode's a little bit funky, but it still exists. You can just write it out, and it should highlight to, in my case, green. And it should be good. So we see something interesting which did not happen yesterday. If you try to build this, everything builds completely fine, which is interesting because when we added the priority, everything freaked out because it was like, oh, you don't have, you're not passing in a task priority. This is because we're giving the identifier a default value here, because we're saying, if you don't include this in the initializer, we'll just set it to be a new unique identifier. There's not really much of a time where we're going to pass in an identifier directly into this. There will be one time, but we'll talk about that when we get there. So as an example, if you take this out, it sort of yells at you because it's like, hey, you're not initializing a task with an identifier. But if we say, well, just take the default value, we just want it to be some random unique identifier, then that's great. And we don't actually have to do much updating at all in order for it to essentially work and just create a new identifier every time a new task is created.
So is this kind of like what we talked about yesterday, where we would initialize it with something, and later on, if we don't fill in the initializers, it'll put a default value onto it, right?
Exactly. So if I just watch me here. So if I call this initializer now, you'll actually see like two versions of the same initializer. We only made one convenience initializer, but now we have two. It's a little bit hard to see, but you can see one takes in the name, notes, priority, and context, and one takes in the name. Here, I'll actually just call them both. So in one, we have the identifier, and that would be where we don't take the default value. So it says, hey, if you want to pass in a specific UUID, you can do that. That's fine. But if you don't, and you use this initializer that doesn't include the identifier, it will just say, oh, they just want me to take, they just want me to take whatever this default value is, which is awesome and perfect for what we're trying to do. Does that make sense? Any questions on that? Okay, cool. So that's our whole migration. That's pretty cool. We didn't really have to do much else besides just changing that initializer. So let's talk about sort of meat of this, which is the synchronization. I want to start off with us sort of assuming that we already have information on the API. So what we're going to do is just all use the same URL today. And then for your afternoon project, you'll actually be making your own like Firebase database. So you're not basically potentially breaking the database for each other, which is a problem we've definitely run into in the past. So what we're going to do is I want you guys to go ahead and copy and paste this code snippet here and just throw it at the top of your task controller. It's just the base URL for that Firebase database. So to start off with, well, we essentially need to do a few functions here. Two sort of main functions, which is fetch tasks from Firebase and then be able to put tasks to Firebase. So that's kind of what we're going to be doing here. So I'm going to put these at the top. If you want, you could put these functions somewhere else. I'm just really putting it so that I can have like this base URL up here on the screen at the same time. But let's go ahead and make a function that's going to do this first part, which is sort of the pulling down from Firebase. And then this part, luckily, is quite easy as far as putting goes. So it's basically just like a put function like we did in Wednesday and Thursday of the networking sprint. I want to make sure we have enough time to talk about this one because this is sort of the meat and more complex part of the lesson. Okay, so let's make a function called fetch tasks from server. And I'm going to have a completion closure here. That's not going to include any arguments. It's just going to be an empty closure here. And I'll make it escaping. We'll talk about that in a second. Okay, so let's do a little review of networking. It's been a couple weeks. This will be good. So when you are building out, you know, a networking function to go and get some information from an API, what are the steps that you take in order to do that?
Make the request URL.
Okay, yeah. I'm going to say set up the URL. Someone else? What's the next step? Or what's another step at the very least?
Make the request itself.
Yeah. So we need to, so I'm going to say create the URL request. And then Brian's coming in with the next one, which is performing the data task. Perform the data task. And then after we finish the data task, so kind of nested inside of that, what do we do in the completion of that data task?
Decode the data.
Okay, yep, that's part of it. The data, put that down a little bit. What do we generally do before that?
The HTTP method.
We're going to check for errors. So Brian said that. The HTTP method would be sort of a part of creating the request itself, but you're not wrong. I've just kind of, it's just sort of a subtask of this, but yes. So check for errors, decode the data, and then, you know, I'm just going to say like, for us, we're going to, let's see, how do I want to say this? Figure out the tasks that need to be created and the ones that need to be updated. That's kind of obviously specific to this one. Thank you for doing that. So let's go ahead and do this. I want to mention one thing, which is Firebase is this little bit of a unique use case where you're welcome to try this in your browser, but if you copy the URL that is in this string right here and paste it into your browser, I'll open up a private one so it doesn't have my credentials logged in. It'll want you to sign into Google, and that's not quite what you want. We just want to get the JSON. And so in order to do that, we have to tack on .json to say, hey, just give me the JSON at this location. Don't, you know, log me into the dashboard that you guys see on my screen. So like we can see here, then that gives you the information that we want. Normally you don't have access to that, but we've changed the sort of rules on here to make it so that anyone can access this. Normally you have to be authenticated, but that's like a whole other topic. So as far as setting up the URL goes, all we have to do is add that .json onto the end of our URL. So let's just say, I'm going to call this let request URL equals our base URL dot appending path extension, not component, and I'll explain that if we didn't talk about it in the networking sprint. I think we did, maybe. Did we talk about the difference between appending path extension and appending path component? No, yes, no, okay. So what appending, here, let's do this. Just throw this into my.
Just to see if I got it. The components isn't the the parameters that we give it, and it changes. I know that the URL.
Sorry, you were a little muffled. I couldn't hear you very well.
Oh no, that's fine. I'm trying to remember. I think the components are the like the little pieces that we append to it after this one.
So it would be like, you know, slash something.
Yeah.
Slash, you know, another component would be slash something else or whatever, right? So what is a path, or what is a path extension then?
Period.
Yeah, it's putting a period there. So in like where we say, just as an example, if we say appending path component, we say something, I don't have to put any, oh, is it gonna yell at me because I'm not using this? Oh, sorry, it's append path extend or component, that's why. Okay, there we go. So we see that even if I didn't have this slash here, appending path component is going to put the slash in there for me. So it's smart enough to sort of figure out where to put those slashes, which is awesome. Appending path extension, on the other hand, do this, say appending path extension, I say JSON, just like, that's weird. Yeah. Just like the appending path component sort of put the slash there for me, appending path extension will put the period there for me. So it's just an easy way for you to make sure that you do it right. So that's all we're going to do is just say appending path extension, put JSON on there, and we're good.
I got a quick question. Like, if you're going several layers deep, right? Do you just put all the components on there, just that comes right after the slash?
That's a great question. You can do you mean like if you have like subcomponent like that?
Yes, correct.
Yeah, you could do it either way. You could do it like this, or I personally, just because I think it looks a little bit cleaner, is I tend to do this where I'd say, man, I keep doing append. Then I would do another appending path component to be like subcomponent. Doesn't look great because we don't have a ton of space in here, but I would really do it like that, just so it's on new lines. But ultimately, you end up with the exact same thing. So it's not like it really matters. Well, I just put the slash here, but it doesn't matter which one you do. I just feel like this one is a little bit cleaner, and I make sure that I'm not in charge of putting the slashes in hopefully the right place. I just like let appending path component do that for me.
Okay, got it. Thanks.
Mm-hmm. Yeah, that's a great question. So that's all we need for the request URL. So let's go ahead and create the request itself. So what we're going to say is just, whoops, not in caps. We're going to say var request is of type URL request. Pass in our request URL. And really, that's all we need to do. There's not, like we don't really even need to set the HTTP method here because it's just going to default to get, although we could if we wanted to. There's no body, we're just getting. So just the request itself is perfect, just like that. Let's go ahead and perform the data task here. So say URL session. Shared.data task with our request, and we could throw in our data. I'm going to underscore the response, and we'll just do the error. I'm going to resume that immediately because if not, I'm going to forget. Hopefully this feels familiar to you. I'm kind of going at a semi-fast pace, so if you need me to slow down, please ask me. That's more than okay. Let's just check for an error. Let's just say like if let error equals error. Let's just nslog that here. We're gonna go kind of basic just so we can focus on sort of this whole thing with updating and creating and not really worrying about using like the network error enum or anything. We could, but it would just take a little bit more time, and I want to focus on kind of the meat of the project here. So we'll just say error fetching tasks. And we'll return. So as far as the data goes, we'll go ahead and make sure that it exists. Status log, no data returned from task fetch data task. Yeah.
Should we also run the completion?
Oh yeah, that would be great. I totally spaced that. Thank you for bringing that up. Yes, let's run completion in both of these for sure. Okay, this is where we're now going to run into a problem, which is basically the first sort of leap that we have to jump over, which is not bad, but we just need to be aware of it. So as an example, let's go ahead and say let decoder, equal JSON decoder. There's not really much of a reason I'm making an instance of this, but that's okay. Or like making a constant for it. But. So let's just say let tasks equal, and then right here is where we run into our problem. What should we decode this as? First of all, let's pull in the JSON and actually look at it. There we go. So this is our JSON. How would we want to decode this as? I don't think we've quite done anything like this setup before. Any guesses? So what does this represent, these four key value pairs?
A task.
Task, right? So then this would be the value of a dictionary. So we can see that at the highest level, it is a dictionary. So then the key for that task would be this string, which is just a UUID. But in JSON, it's just a plain old string. So what we could say is like, this is a string dictionary with a task with a task value. But here's the problem. We never made task decodable or conform decodable. So let's go ahead and do that. And this is where we actually run into the real problem. If we go into our task plus convenience and we say that we want to conform decodable, it's going to yell at us here. And it says, hey, basically it can't create the implementations of decodable and encodable, which are the two protocols that Codable makes up. It can't automatically make those implementations in an extension, which is a problem. Because if we try to go, or if you remember, if we try to go into this task file, it won't even let us edit it at all. And before we could edit it, and it was kind of cool because you'd like add codable conformance and it would work, and then you build it and it would go away. But we have this problem where we can't have the automatic implementation of Codable, which is sort of what we've relied on up to this point. And we also don't quite have the knowledge to implement Codable ourselves. So we need sort of somewhat of a workaround. So what we're going to do is, as we fetch these, we're not actually going to make them into task objects, but what we're going to make them in, like decode them as, is a representation of a task that has the same properties, so like a name, notes, priority, and identifier, but we're going to sort of strip out all of the core data parts of it because that's ultimately what's interfering with this, is because we don't have access to the task class itself because core data is generating it for us. So what we're going to do is basically make a mirror image of this task with all of our properties being the same, but just without anything related to core data, so that we can then decode that properly. So bear with me here for a couple minutes, and then I'll try to explain this a little bit further. But are there any questions on why we can't just make this codable? Okay. So what I want to do is make a new Swift file here, and let's just call this task representation. So I'm just going to say the task representation is an exact copy of the task object in the data model. I'm going to say core data task object in the data model, just without its core data aspects. So it's just a stripped down version of it where it just has the stuff that we care about. Because that's what our JSON has. It doesn't have anything related to core data whatsoever, right? It's just our stuff that we said, hey, this is what represents a task. So this way we can say, all right, let's make a struct called task representation. And this one we can make codable because we're just creating it from scratch. There's nothing saying like, hey, you can't, decode this, or you can't not have this be codable. So we'll say let name be a string, let notes also be a string. I'm gonna make the notes optional just because in theory you could have a task JSON that doesn't have notes because we've kind of said that it's optional already. Then we're gonna put the identifier as a UUID, and we'll do the priority as a string. What's cool about this is the decoder should be able to see that even though our identifier on the JSON itself is a string that represents a UUID, if we say that, hey, this identifier is a UUID, it will go ahead and try to create it into a new, like it will take the string and try to make a UUID out of it. When I say it's going to try, that's because if, again, I have so let's say I have this, I'm going to call this identifier string. Again, just watch me here. So I have this identifier string. What I can actually do is I can say like let new ID identifier equal UUID. And in the initializer, you can actually pass in your own string. So if we say, like this is the identifier I'm getting from the JSON, we can pass it into here and it's going to make it into an ID. The thing with this is we are now dealing with, we're dealing with strings, which just can sort of have all of these, these sort of complications. And one is I can pass in whatever string I want to, but like I said, that UUID is in a very specific format. Like it needs to be in this exact format. So if it's off even just by a little bit or a lot, it's not going to be able to be initialized into an actual UUID object because it's basically not valid. And that makes sense because if I try to put like foo in here, like that's not unique at all, right? So if I try to initialize this, it actually returns nil here. And it says, hey, you gave me some information to initialize a UUID from, but that information wasn't quite valid. And so it's just going to return nil instead of giving you like some random UUID. This is all, oh yeah, go for it.
Yeah, I'm sorry. Can you say what line 3 and line 5 are doing again?
Yeah, so this is just creating, so I'm just going to say creates a new identifier string. I'm going to say as a string. So it just creates a new identifier, which is just this, just jumble of characters here. And then we say .uuid string to just basically pull out just that string itself, not worry about all of the extra properties and methods that a UUID object itself has. Then on this one, what I'm doing is I'm saying I want to make a new UUID with a given string as the identifier. So if we say,
basically just going back and forth, converting one into the other.
yes, exactly. So like, oh, come on, let me copy. Playgrounds, man. There we go. So as an example here, I could just pass in this this just big string, and it's like, cool, that is in the right format. But even if I'm like barely off, it's like, that's not the right thing. Or if I'm really off and just say like, hey, the identifier is Spencer, like that's not a real identifier. And so it's just not going to be able to make it into a real UUID object. This is called a failable initializer. Have we talked about these before? Sort of, okay. Basically what a failable initializer means is you give it you give the initializer some information, and based on that information, it could be that, it's cool, you've got all the information you need to create a new object, in this case, a UUID, or it's like, yeah, the information you gave me is kind of bad, so you basically just return nil instead. And that's the failure part, is this is always going to make this optional here. Instead of it being an actual just UUID, it makes it a UUID optional. And you can see that when you call the initializer, you can see any of these three first initializers just return a normal UUID, because that's like every time you call this, it'll return a full UUID. But with this one, it returns a UUID optional because that string can just not work for making a UUID.
Okay. Before you mentioned that the reason why you create the task representation is to strip out all the core data aspects of it.
Yes.
Can you specify what the core data aspects are?
Yeah, yeah, totally. So like the context, for example, or I mean, really, if you look at like NSManaged object, because our task is a subclass of NSManaged object, it inherits a ton of stuff. All of this stuff, in fact, that you see here on the left is a part of NSManaged object, which is essentially preventing us from like synthesizing or creating an implementation of Codable. We could do it ourselves. One, it would be really hard, and two, it's just because we're in the extension that it can't be done for us. And we don't care about any of this. Like, we're not saving any of this information in the JSON here, if that makes sense. So we're just going to say, let's make something that's going to represent the JSON that we get back, which is just this task representation. And then from here, you'll notice all of this information, name, notes, identifier, and priority, is the same information that we pass into here, aside from the context, which we'll get to create a new task. And so it's not like we need any of that extra information on the side as well.
And the only reason why we're doing that is because we cannot have a Codable, have a extension conform to Codable. Yeah,
that's the biggest reason for sure. Another reason, which I want to talk about after we get into the break, is, well, yeah, I'll talk about another reason after we come back from break. So let's go ahead and take a break, and then we can go ahead and jump into that. I just want to.
But it's only specific to Codable, right? Because we were able to put other stuff to extensions before.
Yeah. Well, no. Actually, I've never really tried. Yeah, it's probably just Codable. Now that I think about it, I've never tried to do an extension of something in a different file with the protocol.
Yeah, because usually when we create a extension, we'll have it conform to a delegate.
Right. But it's in the same file is the same thing. It gets mad because it's in a different file,
Gotcha.
which is weird. And it doesn't really seem like there should be a difference, but there is.
Okay, gotcha.
No, it's a great question though. All right, let's take a break and then we'll come back and talk about sort of finishing up this task representation here. All right, welcome back. Clean this up just a little bit so we can talk about a couple things. Okay, so like I tried to explain, I hope it got across, is we have sort of this checkpoint. Oh. We have this sort of checkpoint here. What the checkpoint actually is in reality is simply the task representation. So right before the break, we were talking about one of the reasons we're making the task representation is so that we can have codable conformance. And that's part of it. But another part of it is even if the task itself could conform to codable, which I'll now get rid of, that would essentially mean as soon as we decode things, it would be like we're directly just throwing it right into core data. And we're not really stopping and checking and having a good time to check if it exists in core data or not. And that's sort of the second problem here. Just to kind of give you an example of why that is. As soon as we, I'll get that in a second. As soon as we initialize a task using this initializer, we say self.init with a context. And what that's effectively doing is putting it right into core data. It hasn't been saved necessarily to the persistent store, but it's kind of sitting in core data. So if we did want to check and see, hey, is this something we want or not, we have to be dealing with these tasks, and it's a lot of work to make sure that you don't unnecessarily remove things, and it just kind of is, I think, a little bit more work than it needs to be. And so ultimately what this checkpoint is a way for us to, so I'm just going to say like the checkpoint equals the task representation. Because we're initializing these objects into non-core data objects, they can just chill in memory as long as we want. They can just sit there until we figure out, like, okay, well, which one needs to go and be updated, which one needs to be created, and which ones do we just not care about. It's just a way for us to not even put things into core data until we're sure that they need to be there or not, right? Hopefully that makes sense. We'll look at it in code, and I think I'll try to come back to this and try to explain this again. But ultimately, that's another reason for making this task representation. So even if, basically what I'm trying to get at here is, even if the task object could conform to codable, I'm not sure I would do it that way anyway. I would still probably make a task representation object anyway, because I want to put things through this checkpoint and not have to put things into core data and then pull them out later if I don't want them. To me, it just seems a little bit easier and like less work. Okay, so let's do that. Now what we can do is, if we, so just to make sure, this is what your task representation struct should look like. That's all we need. Just make sure you've got that, and then we can jump back to the task controller and decode things into task representations instead of tasks. So I'm going to jump back here, and in our decode, let's say task representations instead. And then here it's like, oh yeah, that's totally cool. You can totally do that. Sorry, I just realized I'm going to turn on live issues. There we go. Oh, except we need to try because I always forget that. But now it's like, yeah, that's completely fine. That's a 100% okay thing to do. So now this is where this next part comes in, is we've decoded the data into essentially task representations. We're going to pull it out of this dictionary, so we're just left with just the task representations, not like these string keys, because we really just care about the values in this case. But now we can figure out, which ones out of these actually need to be created in core data, like they don't already exist in core data, or just updated from a new version that comes from Firebase. There's a few ways we can pull the values out of here. Probably, well, the easiest one for me, I think, is just to use the map function, not map values, but just map, and just make a quick closure here and just say, I only want the value, just $0.value, and that will basically ignore these string keys here, and then we're just left with an array of task representations. I think that's probably the easiest way. If you wanted to, you could do, you don't have to write this, but I'm just going to show you. You could do something like for key value in our tasks. Well, assuming that they're not an array anymore. Then we could just say, our task reps or something. That's right, task representation. We could just say task reps, append the value. It's essentially the same thing as what map is doing. It's just doing it on one line.
Real quick, I'm getting an error on my string : task representation. It's
Okay.
not using it as an identifier. Did you make like a variable at the top to bring that in, or?
From, wait, what did you put?
Like I have what you have there, but it's throwing an error on the task representation saying it doesn't exist.
That's weird. Go ahead and go to your task representation.swift file and make sure that if you look on this left pane here in the file inspector, make sure this target membership is checked.
Mm-hmm.
Do you mind sharing your screen super quick?
I'm on another computer. Do you mind if I switch over to that one?
Yeah.
Just wait. It might take a minute.
Yeah, that's fine. Sorry. What's the exact error? It just says like use of unresolved identifier or task representation.
Yeah.
Weird. Just make sure that you're spelling it right, I guess. But I don't know why that would be happening. Just look at in your task representation.swift, whatever you call this struct.
Yeah, I copied and pasted it, and it's still.
Maybe try building it. Maybe it just hasn't built the class representation.
Yeah.
That fixed it. Thank you.
Awesome. Yeah, great idea, Isaac. Yeah, core data, like I said, it's not the best thing with the compiler. Sometimes it just doesn't want to work the way we want it to. So I'm just going to go back to mapping it, but if you wanted to, you could use a for loop to do the same thing. But I'm just going to say I just want to pull out the value and put that in an array here. So now that we have just the task representations, now this is where we can figure out, okay, given all of the task representations that we have, we're just going to go through and essentially say, all right, which ones need to go into the update funnel, which ones need to go into the create funnel, and which ones do we just not care about. And that's sort of our now second task. So I think this is a good time where we can sort of abstract out our logic and not make it so that we have this huge long function. So what I want to do is just sort of pause right here. It should build okay the way that we have it right now, but we're going to leave it a little bit unfinished so that we can write a function and then call that function up in here. So I'm just going to call this like update tasks with representations. And it's just going to be an array of task representation objects. And so now I'm, no, that's fine. So once you write that out, now just go ahead and call this function. I know it doesn't do anything, but now we can actually kind of see where sort of this is going to propagate to. So we're just going to say self update task, and that's going to do all of this sort of logic to filter through them.
Would we need to do that on the main thread?
Why do you say that? I'm just curious.
I don't know. It just seems like whenever we do self dot something, it seems like we have to do the main thread.
No, that's fine. The only reason we have to do self dot here is because we're inside of this closure here. And this closure, basically, because of the way that the capture semantics work, we need to specify, hey, update tasks is something that exists not in this closure, but in self, the task controller. You're right. It's normally because we call a completion closure in the view controller, we end up doing it on the main queue. But no, in this case, we don't need to. That's fine. Kind of, well, that somewhat alludes to tomorrow's lesson, but that's not important for today. So yeah, don't worry about that right now. So ultimately what we need to do is a couple of things, and I'm just going to break this down and say which identifier, or yeah, well, sorry, which representations do we already have in core data? And then based on that, so kind of going back to the drawing here. So let's say on Firebase, we've got these three here, T1, T2, T3. Let's say we've got T1 and T2 in core data already. So what we need to do is figure out which ones we have in core data. We basically need to perform a fetch request and say like, hey, I'm looking for these specific tasks. Do you in core data have any of them or not? And then from there, we can figure out which ones need to be created, because if it returns these two, we know that, oh, sweet, we fetched T3, but we don't actually have it in core data. So we can go ahead and throw that in the create funnel to actually create that and throw it into core data. So that's going to be our first part. And then we need to figure out, okay, well, which, so I'm going to say based off of that, we can figure out which ones we don't have, sort of just by extension. And then we can say update the ones we do have. That's kind of what we need to do here. So we're going, yeah, well, I'm going to write out some code, try to follow along with me. I'm going to try my best to explain it, and then we'll kind of walk through it once it's all written out. In order to sort of answer this question of which representations do we have, we need to basically come up with a more complex fetch request. And in order to do that, we need to figure out, well, which representations did we even fetch from Firebase here? And so what we're essentially going to use is the identifier in order to figure that out. So we're going to say, well, I can ask core data for example, I can make a fetch request and say, I want you to fetch all of the tasks, or I can be as specific and say, literally as specific as fetch me this one task with this single identifier. So we can go from very broad to very narrow in our fetching. And that's exactly what we want to do, is just fetch the tasks that we are pulling out of Firebase. So what I'm going to do is I'm going to say we need to figure out, well, basically it's taking these representations and just getting their identifiers, because ultimately that's what we sort of care about getting, or that's essentially how we're going to figure out what's in core data. So I'm going to say let identifiers to fetch equal, I'm going to say our representations, just this array of task representation objects. And again, I'm going to call the map function here. And I'm just going to say, hey, just give me each identifier. So I don't have anymore an array of task representations, but instead, I'm now just saying, just pull out the UUIDs and give me an array of just each UUID from all of those. So it's like if T1, T2, T3 have their own identifiers, we're saying, I don't care about the name, the notes, or the priority, just give me sort of an array of each one's identifier. So then this is the somewhat complex part, and I'll walk through it in a few minutes here. What I'm going to do is I'm going to say let representations by ID equal, and we're going to call the dictionary initializer, which isn't something we do very often, but I'm going to use this unique keys with values. I'm going to use this really cool function called zip. So what it takes in is two sequences, and basically every collection type is a sequence, so it can take in two arrays, two dictionaries, two sets, etc. And what we're going to do is we're going to sort of combine them together. So what I basically want to come up with is a dictionary that looks essentially like this, where we have a UUID as the key, and then a task representation as the value. So we've got an array of task representations here that we've just fetched from Firebase, and we've got an array of UUIDs that are coming from the same representations, but we've just extracted out the identifier. And so what we're going to do is make this dictionary from these two collections. And I'll talk about why we're doing it when we get down into the code in just a second. So what we're going to do is we're going to say we want to pass in the identifiers to fetch to be the keys, and then the representations to be the values. And what we end up with is exactly that, where we have a UUID as a key and a task representation as the value to that key. Hey, again, this is like, I'm just going to make a comment, and you're welcome to write this as well. I kind of encourage it. I'm just going to say make a mutable copy of the dictionary above. So all I'm going to say is var tasks to create equals our representations by ID. Again, I'll explain why we're doing this. The logic isn't the most straightforward, but I will definitely walk through it, and I think it'll make sense overall when we finish this whole function. Okay, so this is where we can actually perform the fetch and figure out which ones we have and don't have. So in order to do that, we're going to set up a fetch request. So just watch me here. We're basically going to go and do somewhat in a similar way of what we did on Monday, which is just creating a fetch request and performing it. Just turns out that the fetch request is going to be a little bit more complex, but not hard by any means. So what we're going to say is I'm just going to put this all in a do catch block here, and then just throw these comments up in the do catch. All right, so let's create this fetch request. So we're going to start it out the exact same way that we normally would. I'm just going to say a fetch request, be of type NS fetch request, and have that be fetching tasks specifically. Then we'll say it's equal to task dot fetch request. So yesterday we looked at customizing the fetch request a little bit with sort descriptors, where we actually said, hey, I want you to sort this information. And we can also do that as well, but we're going to use a different property on this, which is a predicate. Predicates are so cool. I don't know why I get like so pumped up about predicates, but I think they're awesome. I used to use them a ton, like for like things with like CloudKit and stuff. So they're used not just for core data, but they're used like in a few different places. So let's look at predicates. Oops. Okay. All right. So it says it's a definition of logical conditions used to constrain a search either for a fetch or for filtering. I'm not gonna, well, yeah, for in-memory filtering. The best way that I could say, like if you want to remember what a predicate is just a way to filter something. We're just constraining some requirements. So as an example, every fetch request actually has a predicate. And so there are, if we say the fetch request.predicate equals NS predicate and we open up the initializer, we're greeted with a few different ones. And it can look a little bit overwhelming, but I promise it's not that bad. The one that is there by default is this value with a bool. What this says is if you say that the NS predicate's value is true, that says fetch every task. Just fetch them all, and that's the default. If it's false, on the like on the flip side of that, it would say fetch no task, and that doesn't really make sense, but it's just a Boolean to just give you that option. So that's not super useful for what we're doing. I'm just saying, well, we could, I mean, you could have a lot of tasks in your core data store, but really the ones that I care about looking at specifically here are the ones that I just fetch from Firebase to see, do I have it or not? We're just making it so it has to do less work. So what we're going to use is one of these format ones, and this block is actually new. I haven't ever used it before. And then the coder kind of exists on everything, so you don't have to worry about that. This format, though, is the one we're going to use. I tend to use this first one, but you really, all of these end up working the same. So go ahead and call this initializer here with the format and args. Predicates are a little bit weird the first times you use them because they are written in Objective-C. So what a predicate looks like, let's go back to the documentation. I think there's a decent example. Yeah, something like this, like grade equals 7. So what we do is it's basically like an old school if statement, essentially. It's just some conditional logic that returns Boolean. So we're going to say, you know, grade equals 7, and it would fetch every student with that is in 7th grade. Or we could say identifier equals a very specific identifier, and it would just fetch us that one identifier, or anything with that identifier, but we'd assume it would be only one thing. We can also go into sort of more complex things like passing in a whole array of identifiers and say, hey, does the identifier of anything in core data match any of these identifiers in this array? And that's what we're going to do today. The format is the problem, well, not the problem, but it's a little bit weird. You see that it's a string. And so what they essentially want you to do is say like, identifier equals, like all that just jumble of characters. And that's how you could say like, get this very specific identifier. The problem here is because this is written in core data, we can't actually use string interpolation. It won't work, and it'll actually, I can't remember if it crashes or if it just yells at you when it tries to run this, and it's like, yeah, you can't do this. And so what we have to do is we have to use what are called string format specifiers in order to basically interpolate some value. So what I want to do is go to Realm, because they have a suite. Oh, not. Realm is like basically a competitor-ish to core data, but they have this really nice cheat sheet on predicates. So I'll send that to you just so you can look at it in your own time. But ultimately what we want to do is something like this, where we have used this in operator. So it says, the left-hand expression must appear in the collection specified by the right expression. So name in an array of milk, eggs, and bread, for example. So what we're going to say is identifier capital in, and then we have to use sort of the Objective-C version of string interpolation, which is a % sign and then an @ sign, like that. Oh, and I'll pull up the string format. Yeah. Oh no, they get rid of it? Oh, that would be a bummer. Dang, I just taught this like a month ago and it worked. Oh, maybe just their website's down. Okay, well, I'll paste this to you anyway, and then it might be that their page is just down right now. But what this would do is it would show you a list of different like % something based on the type of the object. So for an example, %@ represents an object, so like an instance of a struct or a class. Like %d is like a number, etc. And you kind of go from there. But it would list all of those out, and you don't really have to worry about these until you get to Objective-C. But essentially, what we're doing is, oh, whoops. Oh, here, no, there we go. We're essentially making a string that essentially says identifier is like, yeah, I guess it would be something like our identifiers to fetch dot contains the identifier, more or less. That's essentially what we're doing. It's just in the format of a string. Looks a little bit weird. So what we're going to do is go ahead and basically on this second part here, we pass in what we want to interpolate in this %@. So whatever you put right here on the right gets thrown in where this %@ is. So what we're going to do is the identifiers to fetch. So we pass it this array of UUIDs and we say, hey, go ahead and fetch all of those, any task that has an identifier that is in this array. And that's essentially how you use predicates. They're a little bit weird. Oh yeah, sorry, go for it.
Quick question, on line 79, right, on your comments, to get the comments to start over there, like the cursor to go over there, you just press tab, right?
Yeah.
Is there a setting, because when I press tab, it goes to the next line?
No, well, if you have like that, it was getting a little bit mad at me because I had this right here that needed to be auto-completed, and when you hit tab, it kind of defaults to going over to that.
Right.
So I had to oh man, I have to write that again. But no, it should, I haven't changed any setting to make tab just go over.
Okay, I'll figure it out. Thanks.
All right, sorry.
No problem.
So now this is how we say only fetch the tasks with the identifiers that are in this identifiers to fetch array. That's essentially what we're doing there. Looks a little bit weird, but this is exactly how we are sort of filtering, or we're constraining this search to say, like, let's say we have 1,000 tasks in our core data persistent store, and maybe we only fetch 15 from Firebase that are on there for whatever reason. It would be a lot more work than we need to fetch all 1,000 of those and put them in memory than it would be to just say, only fetch me like any of these 15 that you have. And so at the most, you'd be fetching 15 tasks instead of 1,000. So it's just much more efficient that way. So now that we've set this predicate, we can go ahead and execute the fetch request and get these tasks. So I'm going to say, let's call this like existing tasks. And we'll say, try our, oh, you know what? Let's actually just for, not really for fun, but let's make a variable for our context. So we're going to say core data stack share main context. More than anything, just to kind of keep it a little bit cleaner, and also because we're going to mess around with that tomorrow. So I'm going to say context.fetch, and we'll throw in our fetch request that we just made. So now we'll get an array of task objects from core data. So these are the ones that are in core data that also exist in Firebase. Can you guys give me a 1-3 on how you feel with just like this part of the fetch request? I know there's kind of a lot going on here with like this zip and everything, but do we feel okay with how the predicate itself is working? Okay. Is there anything I can clarify? Anything you'd like me to try to explain again or in a different way?
I think for me, I just need some time to process it.
Okay. Yeah, I totally get that. This is kind of a lot here. But once you get this, like the implementation of this would be essentially the same for any, server-side database that you're trying to access. So it's kind of like a one-size-fits-all kind of use case, which is nice.
Could you make the predicate anything in the model, or does it have to be the identifier?
Yeah, it could be anything in the model. So all it's looking for is, because we've said that our fetch, thank you for bringing this up. I didn't really explain this at all. Because we've said that our fetch request is specifically fetching tasks, then in the predicate that we attach to that fetch request, we say we can access any property that the task itself has. So if we wanted to, we could say name is, like, just to be easy, we could say name equals task or whatever. Like it could literally be whatever you want it to be. Oh, sorry. There we go. You could make it whatever, right? You could say name is Spencer, and it would only fetch tasks named Spencer. So yes, it can work with any property on your model object. Thanks for bringing that up. That's an awesome point. All right, so from here, now we can really figure out, okay, we know which ones we don't have, because we can basically say, all right, if, for example, again, if we have 15, if we have 15 tasks from Firebase that we just fetched, and maybe we only pull out 10 from core data, then we know we have 5 that we don't have in core data, so we can create new ones from those. And then those 10 that we do have, we could just say, well, we're assuming that Firebase is sort of the source of most up-to-date information, so we could just update those 10 that we did get. So let's go ahead and say that we'll just update them first, and then we'll talk about how to create the new ones, because that's actually easier. So what I'm going to do is just say for task in existing tasks, let's just go ahead and update them. So we could say, basically all we need to do is we have a task. Now we need to figure out, so this is like an actual like task object, like a core data task. So we need to grab the task representation that corresponds to this task. The way that we're going to do that is by using the tasks identifier, and this is going to kind of go back up to this stuff that we made up here. So I'm going to grab the identifier. So I'm going to say guardlet identifier equals task.identifier, just because this is optional. And then I'm gonna put a comma. I hope this makes sense. We could, well, yeah, I'll talk about it. So then I'll say let representation equal, and then we're going to use this representations by ID dictionary, which again is a UUID and task representation dictionary. So what we can do is we can say, I've got this identifier. So now if I pass in the identifier to this dictionary, it will give me the corresponding task representation for that. And we can just say representations by ID, pass in the identifier, and then that representation should be the task that is ultimately coming from Firebase here. Here. And so we'll just say, if neither of those are there, then I'm going to call continue. We talked about continue before? No? Okay. I'll jump back to that once we sort of finish this for loop, and then we can talk about that. It doesn't really matter for kind of what we're going to do below here. So once we have that task that's from core data, and we have the representation that's from Firebase, now what we can say is, all right, well, let's just say task.name equals our representation. .name, and do the same thing for the notes and the priority. And that would be updating the task that we do have. So again, going back to like the example of when I ran this last time, it went from like Z created task to created task because that's how it was in Firebase, just created task and it didn't have the Z there. So this code right here is what is doing that updating of an existing task. And then what we're going to do is just basically say, all right, we're done with this task and this task representation. We don't need to create a task for this because it already exists. So we're just basically saying, don't worry about this. So what I'm going to say is tasks to create. We're going to remove value for key identifier and say, just updated a task. This, we don't need to create a new task for this identifier. So that is coming back from our var tasks to create right here, where we just have basically a copy of our dictionary. And we're just making it so that, hey, this is going to keep track of all of the ones that we need to create. But ultimately at the start, it has like all 15 of those tasks. But as we loop through and update each task, we're going to say, well, you don't need to create a task for this one or this one or this one. And then it's ultimately left with just the tasks that we do need to create that didn't already exist in core data. And so it's just, you know, going to loop through all of the existing tasks that are from core data. So let's talk about this continue. Continue is used when you're inside of a loop, like a for loop here. If we said return here, what would actually happen? Oh, you know what? I can actually illustrate this pretty easily. I'm just going to say if I is 10, or we'll just say 5, then we'll return. What it's going to do is, oh man, not in the function. Okay. Sorry, playgrounds are a little bit weird. There we go. So we see this if statement is calling return, and that's essentially like this else statement right here. If we call return here, what that actually says is completely stop the for loop, like you're done. You cannot, finish. It just says we're done with the whole for loop. You don't need to keep running these. If we say continue, however, it says, hey, all right, well, then just don't continue, or well, that's confusing. Don't run any code below this, if it's 5, otherwise like it's fine and you can just continue with the next iteration of the for loop. So if we run this now, we'll see that it prints everything and it just sort of skips 5 because it said, all right, well, this iteration of the loop is done, but it'll just, go to 6 and keep running. Does that make sense?
Can I just clarify? So it'll just skip one iteration of it, or skip whatever the condition is, and then go to the next one.
Yeah, it like finishes the current iteration of the for loop, but it still keeps iterating.
Okay.
It's just an early exit of that one iteration, whereas return just says like finish the for loop. I'm completely done with the loop. You don't need to keep iterating through. That's kind of what's going on there. So as an example, what we're doing here is we're saying, well, okay, if we have an identifier, great, but maybe for whatever reason there's no representation for that identifier, or maybe there is no identifier. Then we don't want to prevent other tasks from potentially being updated because maybe those do have an identifier. So we're going to say continue here and say there could still be good, tasks that we can update. So we'll just continue and have it basically continue iterating instead of just stopping and potentially not updating tasks that could be updated. All right, we're almost done, guys. So the figuring out of which ones we don't have is essentially done. So now we can just say, well, we've essentially done that. So let's just create a task for all of those ones that we don't have. Oh, sorry, not a function. So we're going to say for representation in that tasks to create dictionary. I actually only care about the values here. We don't need those keys anymore. Then we have a task representation, and that has all of the information we need to create a task. So we can just pass those values in. We've kind of got two options here. What we could do is just call the task initializer and pass in each of these things individually. I think a cleaner and better way to do this would actually be to just create a second initializer that takes in a task representation and does all of this in there. Just so that if there's another place where we need to create a task from a representation, we don't have to rewrite out all of this code again. Let's do that. Let's go to our task plus convenience file. And I'm just going to make another initializer. And we haven't really explicitly talked about this, but you can have as many initializers as you want. And that's kind of the cool part. Like if you get some information one way, right, like from user input, great. If you're getting your information from a task representation, that's cool too. Just write another initializer. There's nothing wrong with that. I'm going to make this also discardable result just so it won't yell at me. But it's just, again, going to be a convenience initializer. And it's just simply going to take in a task representation because that's ultimately what has the information. I'm just going to say task representation. But we're going to make this a failable initializer. And in order to do that, all you need to put is a question mark right after the init. I don't assume that this would ever not work, but it's better to be safe than sorry. So what we're going to do is make it failable and say, hey, maybe a task representation doesn't quite have the information that we need. And I'll kind of show you what I mean by that. We'll also include a NS managed object context. There we go. So it's somewhat of a use case, but it's still quite possible where maybe over here, really the only time that this could not work is if we, like, somehow this identifier got changed, like foo, right? If somehow on the server side that got changed, we're not able to create an identifier from that because it's not a valid UUID. Similarly, if we change the priority to, something else like super critical, like that's not something that exists, and so it wouldn't be able to make that enum case. It'd be really weird if that happened, but still it's possible. So we're going to handle that we're just going to say guardlet our, we'll just start with the identifier. We'll just say guardlet identifier equals a UUID, and we'll initialize the UUID, call the UUID string initializer, and we'll pass in that task. Oh, you know what? Actually, the way that we're doing it, we don't actually need to do that because I just realized the identifier itself is a UUID, but we will need to do that for the priority. So let's say guardlet priority equals task priority with the raw value, and then this is where we'll pass in the task representation dot priority string. This raw value initializer, if you look at it, is also, if I can get it, this is also a failable initializer. You see that it's returning an optional here. So, we could pass in a bad raw value string that isn't one of those cases, and so it could make it so it doesn't work. So we're going to say make sure that that's like valid. Otherwise, we're going to return nil here, and that's the essentially the power of a convenience initializer is it lets you return nil at any time if you say there's not enough information for me to create a task. And then what we can do is we can just say, well, we're going to do self.init, but because self.init doesn't autocomplete, we're going to say task.init. And this is a perfect example of us sort of chaining multiple convenience initializers together. If we wanted to, we could just go ahead and basically do what we're doing right here. Well, actually all of this right down here and just sort of copy that code. But since we already wrote that out, we could actually just pass those values in individually and save ourselves a little bit of work and time. And basically we're not repeating ourselves. So we can just say, we'll do task representation.name, task representation.notes, priority, task representation.identifier, and for the context, we'll just pass in whatever context is passed into this function here. Oh, sorry. On the first initializer, let's just make the notes a string optional because that's essentially what we're kind of saying it is going to be. And then instead of task.init, just put self.init, and then it'll stop yelling at you. All in all, we're essentially just taking one task representation and including a context so that we have all of the information to just create a full task object from this. Are there any questions on this initializer here?
Mine is saying that The notes have to be unwrapped.
Yeah, so did you make this optional right here? Sorry, I did that quick.
Oh, yeah, I missed
That's
that.
my bad. I just did that. I didn't really explain that super well. We're just making it so that we're essentially saying that notes are optional in this app. So I just forgot yesterday, or when we made this on Monday, to make this a string optional in the initializer itself that we're calling down here.
I have an error with the raw value.
Okay, what does it say?
Let's see. It says incorrect argument label in call have raw value and it's expecting from.
For task priority?
Let's see. For line 40, where it says raw value for you, it's expecting a from. Oh, task priority. Okay.
Yeah, it shouldn't be a task. It should be task priority.
Okay, got it.
Or maybe task representation is what you had.
Yeah, I had task representation.
Yeah, that's coming from Codable. All right, so now what we can do is jump back here, and now all we need to do is just say task, call that initializer, and pass in our representation and the context that we have from above. That's also another reason why we made this context constant up there. And just do that, and it's only going to create a task for ones that we didn't already have and we haven't already updated. And so after all that is done, we're going to persist those changes, and we're going to say core data stack shared save to persistent store. This is all the changes creating of tasks to core data. This So what we're going to do is just make all of these changes where we create all of the new tasks and we update all of the tasks that we already had, and then just save those all sort of at once into core data. If you really wanted to, you could probably call it a couple times in here, but it's definitely overkill for what we're doing. And then in our catch statement, the only thing that really we're trying that's a throw method is this fetch. So we'll just say nslog error fetching tasks from persistent store, and we'll pass in the error. And finally, the last thing we're going to do in here is just call completion. Whoops. Please. Wait, do we have a completion in here? Oh, no. Oh, sorry, that's in the other function. We're good then. That's all we need to do in here. So this is a lot. Let's So I know we're out of time. I want to run through this one more time. We'll call this function, and then we just have the put function, which is very easy. It'll take us 2 minutes. Well, take us like 5 minutes, but I just want to make sure that we feel comfortable with this, because I know this is pretty dense code. This is probably some of the most dense code you've we've had before. So this first part here with sort of these three things is we are essentially creating a dictionary of all of the tasks that we fetch from Firebase, and as the values, and then the keys are going to be just each task representation's identifier. The reason we do that is because after we've fetched all of the tasks that we want to see exist in core data, we ultimately start removing those key value pairs, those task representations from this dictionary, this task to create dictionary. So we essentially start out with, again, our sort of 15 tasks. And I'm just going to say that could need to be created or updated. And so what we end up doing is we end up saying, hey, we just updated a task, so that can be removed from those 15 tasks, or that dictionary of 15 tasks. And so then it goes down to 14 until we've basically updated all of the tasks that already existed in core data. And then we're left with any tasks that don't already exist in core data, and we go through those in the task to create. So this could be, maybe like 5 tasks that don't exist in core data already, or however many it is. And then we ultimately just create a task out of those. And then once that's done, we've done sort of both of these funnels here where we create some and then we update some as well. I know this is a lot, but are there any questions on really anything that's going on in this function? Okay, I just want to point out, in your afternoon project, you'll be doing a similar thing, and that means you can follow this fairly line by line. So don't feel like, when you get to the afternoon project and it's asking you to do all this work, that you don't know how to do it, because you can just reference this and be like, oh, okay, and you can follow this. And even if you are having to copy and paste a lot of stuff, that's okay. That is a part of learning. I would say, it can become a crutch, but for something like this, if you don't fully understand it line by line, copy and paste it and try to go through it line by line. But I 100% understand that it just comes with time, and that's something that you have to sort of build up to. So let's go ahead and call this, and the place we're going to call it is just in the table view controller. This is actually really cool. This is a time where we don't really need to do anything. What we did was we included a completion here, but we don't actually need to do anything after we call this function. So what we can actually do is we can give a default value to this closure here, just like this, and then you'll kind of see what happens. Let's actually do it like this. I kind of want to keep everything in this task controller. So let's call the initializer for our task controller. We're just basically making an initializer, and we're not having it take in any arguments, but we essentially use this as the, using this initializer as the sort of view-did load of the task controller. That's essentially kind of how you could think about it. It's like just a place where we can call some code. So as soon as this task controller is initialized, we're immediately going to call the fetch task from server function. And so now we get 2 choices. Once you add this default value for the completion closure, it says, hey, if you want to do something, go for it. You can, print unfetching or whatever, right? But at the same time, if you don't care to do anything, you can just call this function, and it looks like it doesn't even have a completion closure at all, because it just takes this default closure here, which is kind of cool. So let's run this, and it's going to work. I'm a little bit curious to see if anyone can figure out why this ends up working, and we don't need to tell the table view to show all of these new tasks. Oh, what's going on? Oh, okay, never mind. So I'm going to go ahead and you don't have to do this, but I'm just going to close the app, delete it. So there's no core data persistent store anymore. And then we should make it so that we get these on the screen anyway. Can anyone think of why we don't need to reload the table view here? To have it like show them on the screen? Okay, that's totally okay. The reason that we don't have to manually say like, hey, we got some new information, go ahead and reload the table view is because back in our table view controller, the fetch results controller is going to notice that. So you'll see if I put a breakpoint like on our, let's do this. You can just go ahead and watch me here. You don't need to do anything. So I'm going to delete this again so we've got nothing, and we'll just kind of look at the flow here. So we see that there's nothing on the table view yet. We hit this where we create a task. We're going to save it, and then the table view is going, or the fetch results controller rather, is going to say like, oh, sweet. There's a new change to some object and one was just inserted or created into core data. And so it automatically will go ahead and add a cell for us. And so we just kind of get that for free, which is pretty cool. All right, guys, I'm really sorry we're going over time. I feel super bad. What I'm going to do is I'm going to give you a code snippet in just a second. We'll walk through it, but I don't want to take the time to write it out. So let's make a function to put the tasks to Firebase, and then we'll be done. So we're going to call this function just like put task. And then this is another time where we could use a completion, but we could not. So I'm just going to give it a default value of an empty closure here. So ultimately what we want to do is we want to find a unique place to put this task. So I'm really excited for you guys to do this in your own project with your own Firebase database, because you can kind of mess around with things and it doesn't matter. But you'll see if I click on this node here, what it actually does is we are placing a task at a specific key, but really what it's doing is it's just making a new path component onto the end of the URL so that we don't overwrite the data. So what could happen is if we were always putting our tasks directly at this base URL, it would just overwrite whatever was there. And so we just want to make a unique URL. And then what we're going to do is just go ahead and encode our task representation. So what we're going to do is we need an easy way to turn a task into a task representation. So let's all go to the extension, our task plus convenience here. And I'm just going to make a variable called task representation, that is of type task representation. It's just going to be a computed property that makes a task representation. It's I think, fairly straightforward. So all we're going to do is we're going to say we need to return a task representation. The problem here is we start to notice that basically everything is optional. Well, everything is optional on our task. So if we pass in our name, the name here is optional, even though it really won't be in practice. So what we need to do is just unwrap things. So we'll just say guardlet our name equal name. We don't have to do the notes because that's a fine time when it's optional, but we will need to do it for the priority and the identifier as well. And we'll say let identifier equals identifier. Else we'll return nil. Along with that, let's make the task representations type be optional so we can actually return nil here. Otherwise, if we do have that information, now we can pass in the name, notes, identifier, and priority, and have it work just fine. So essentially what we're doing here is just the opposite of what we did with this new convenience initializer, where the convenience initializer takes in a task representation and creates a task. We're just going the other way, where we have a task and this is going to create a task representation so that we can throw it onto Firebase. Okay, I'm going to go ahead and Slack you this code snippet. I'm not happy or proud that we have to do this, but I don't want to take any more time away from your lunch by writing this out. But we will go through it line by line. It's not any hard code. It's just sort of time-consuming code. Mostly, it's stuff that you've done before. Oh, it looks like we will actually have to include the HTTP method enum, though. So I'm just gonna go ahead and grab that enum just for the sake of putting everything on the same line, or on the same screen. I'll just put it right above the function, but you can put this enum wherever you want. And then we'll walk through this here. Although I do get a little bit wonky with, oops, there we go. Okay, so really all we're doing is sort of in a very simple way is we're just saying, I have this task, I want to put it on Firebase. So all we do is we just encode that into data. So we're going to say, encode the task representation, and we just get that task representation from that task.task representation computed property that we just made. There's one thing that is a little bit unique here, which is this first part. This is where I said we're not going to give a task that maybe didn't have an identifier from a previous version of the model version. What we're going to do is we're going to say, hey, the identifier that we use to sort of tack onto our URL here is either the task's identifier, or if it doesn't have one, we'll just say we give it a new one, and then we're going to assign that identifier to the task so that from then on, it does actually have an identifier and it stays the same. So we just make a URL by appending that UUID string path component. And just like for getting the JSON from Firebase, you actually have to add the .json path extension to put onto Firebase as well, the way that we're doing it. So then we make a request and say we want to put, we grab the task representation and encode that into data and set that as the request's HTTP body. And then we perform a very, very simple URL session data task, which is just going to go ahead and put that data there. And we don't need to decode the data or anything because we just put. So we're just going to check for an error and then call it good there. And then, there's not really anything after the fact that we need to handle. So the question is, where do we put this function here? Where do we call this function? What do you guys think? How could we make it so that whenever we change a task, we also change that on Firebase.
Do we put in our CRUD methods?
Yeah, exactly. We would just put it in our CRUD methods. So we've pretty much already got those CRUD methods here. So what we can do is just say, after we create a task and put it in core data, let's just say, let's call our put task function. And now this time I am actually going to create a constant for my task because I need to pass it into the put function. And then same thing with the update task. We'll just call put task. And this is this is an example of where we don't really need to do anything in that completion closure after this put finishes. So I'm just going to kind of let it use that default empty closure and just say we don't need to do anything, but it's available if we do want it. And in this way, that is accomplishing this right here, where we go from our phone over to Firebase. I put in the save IB action, but the save IB action is just calling this create and update task in the action itself. Okay. Again, I apologize that we didn't have time to like walk through it and write all this out. Are there any questions about how we're putting the task as far as this put function goes, as far as that task representation computed property that we made goes? Anything about that? Okay. Can you give me a 1 to 3 on how you feel with the putting and saving the task up to Firebase goes? Okay, that is 100% understandable. And again, and I apologize that we didn't have time, but I feel super bad that we go over time every day, and I just don't want to prolong that anymore. So that is the whole project. Everything should work now. So what we can actually do, then this is pretty cool, is I'm going to go back here, and you guys feel free to actually run the project and create a task, and we should all see this. So then the next time you run the project, it's going to fetch everyone's that they just made. So I'm just going to say Spencer, October 16th. Hello. Hit save, and that should put it onto Firebase. Okay, so it looks like GPO got it working. So if you run it now again, like I'll get GPOs. Whoops, sorry, breakpoint. There we go. Isaac got it. So it's kind of cool. You can just, all be posting the same place and pull all that down. So, all right, guys, that's everything I've got. We'll head out to lunch now, and go ahead and please take a full lunch. Don't cut your lunch short. And we'll talk to you in this afternoon. Thanks, guys.
Quick question, Spencer.
Oh yeah, go for it.
I, for whatever reason, in the create task, like the put task, it's saying use of unresolved identifier.
Oh.
But it's fine in my update task.
Oh. So I just made this right here on this line. It used to be like that, so I just said let task equal that.
I can't see your.
Oh, yeah, that'd be helpful, huh? Sorry about that. So before on my line 178 here, it was just like this. Said let task equal that, and that's where this task is coming from.
Got it. Cool. Perfect. Thank you.
Yep, you're welcome.
Bye.
Any other questions from anyone before we head out? Okay, cool. Thanks, guys. I'll talk to you later. See ya.